Hi, I'm Professor G, and I'll be teaching you physics today. So the topics that we'll be covering will be Newton's first law, vectors, equilibrium, net force, and support force. Even before we jump into Newton's first law, let's look at some introduction and history. Even before Newton came in, there were other scientists who were actually working on this already. So Aristotle was the first person to come up with this idea. He talked about, an object or moving object must be propelled by a steady force, right? Steady force. What does steady mean? Steady means uniform force or constant force or non-changing force. And Galileo, who came in, he completely turned this around by saying, in the absence of a force, an object or moving object continues to move, right? So now Newton refined Galileo's idea a little bit and called it as Newton's first law. Now Newton's first law is also called as law of inertia. Inertia is the tendency of an object to remain unchanged, right? The keyword here is continuous. So an object continues to move, or an object continues to be at rest unless and until an external force acts on it. So Newton's first law, right, states that every object continues, see the keyword continues, in a state of rest, continues to be at rest, or of uniform speed. Uniform speed is steady speed, or constant speed. It continues to be moving at constant speed in a straight line, right? It's not going to change the direction. It's going to move along the straight line unless, of course, acted on by a non-zero net force. We're going to talk about net force later. Net force is just a combination of all the forces that's actually acting on a given object. So, okay, even before we look at vectors, let's look at physical quantities. Any quantity in physics is actually called as physical quantity. So all these physical quantities are grouped either as vectors or scalars. Before we talk about vectors and scalars, let's talk about two important things. One is magnitude. Magnitude is how much, right? And then we have direction, which means which way, right? The direction. Okay, so having these two, we are now going to define our vectors or scalars. So for scalars, for a physical quantity to be a scalar, it's described by magnitude only. Okay, so there is no direction associated with a scalar, versus vectors are described by both magnitude as well as direction. Okay, so there are multiple, let's look at some examples for scalars as well as vectors. It gives us a better understanding of what we are actually talking about. Okay, so for example, let's say 10 meters, right? Look at this, 10 meters. It just says 10 meters. It does not give us any direction. So 10 meters as it is, right? This distance, it's just a scalar where it doesn't talk about direction. Now, if I want to, bring in my direction, now I will say positive 10 meters. So this means that, the 10 meters that we have, which we called as the magnitude, now this positive or plus sign becomes our direction. Okay, let's understand this a little bit more. Okay, so you see how you guys, hopefully you guys remember your number line. Okay, anything false on the right side of the number line is positive, false on the other side or the negative side is going to be negative. So this is your positive part, that's your negative part, just to understand better. So when I say 10 meters, that means my vector or my physical quantity is actually covering 10 meters, right, in this particular direction, because it's plus, so it's going to fall on the positive side. Now if it is just 10 meters wherein here, which is a scalar, it does not give us a direction. So when a physical quantity is described just by magnitude only, how much, right? How much distance does the object cover? That becomes a scalar. When we get the complete picture, complete idea of an object traveling 10 meters on positive side, so that will be your vector. So let's take another example. Say I'm going to take in velocity now. Velocity, right, is a vector. Okay, velocity vector, I'm going to say plus 40 meters per second. Okay, so now this 40 meter per second is the magnitude part. That gives us the speed, right? The speed with which an object is actually traveling. It's traveling at 40 meters per second. Now, where is it going? It's moving in positive direction. So this is your direction part. You see how easy that is? Okay, there's another way of writing the same thing, just to get this a complete picture. Okay, so you can also see this 40 miles per hour, right? An object is traveling 40 miles per hour due north. Okay, so this means that an object which is traveling at 40 miles per hour, along the north direction. So this is how we actually define vectors. And some examples of scalars are, your mass, right? 10 kg. Let's say an object weighs 10 kg mass. That has no direction. Let's say the time component has, 2 seconds, 3 seconds, right? No direction. So on and so forth. There are multiple, scalars in physics. Same case with vectors too. There is force, there is velocity, there is acceleration, just to name few. Let's now look at adding vectors. When can we add them? So when we have vectors acting in the same direction, then those vectors add. When we have vectors acting in the opposite direction, then they subtract. Straightforward, simple rule. Okay, now when we add two vectors, it results with a resultant vector. Okay, and this particular resultant vector is denoted by letter R. Okay, so let's say we have vector A, and then I'm going to add that with vector B. Now this vector addition results with a resultant vector R. Okay, now once we have understanding of resultant vector, now we move on with our next topic, net force. Combination of two or more forces irrespective of addition or subtraction, we call it as net force. Okay, net force. Net force is denoted by net force. So this particular symbol is called as summation, or in other words, sum of all the forces acting on a given object. So combination of forces irrespective of addition or subtraction is called as net force. Let's take an example. Now let's say you have an object here, right, which experiences multiple forces here. Now let's say I have 70 Newton, right, which is acting to the right hand side. So I have positive 70 Newton. I have another force which is also acting in the same direction as my first force. Now when forces are acting in the same direction, what do? We add them together. So my net force, sum of all the forces now will be my 70, right, plus another 70 results with 140 Newton, and that would be my net force for this particular object. Now let's take another example where we have forces acting in opposite direction. So I have first force which is acting in positive direction, 70 Newton. I have another force which is acting in the opposite direction, which would be 30 Newtons, let's say. Okay, so what do? we have two forces acting in the opposite direction. So I have 70 Newton minus 30 Newton, right? Results with 40 Newton. So the direction now that I'm going to go with would be the direction of a bigger force. Now in this case, the bigger force is 70 newtons, and that is the reason it came first. Or we can also visualize in the number line, you have 70 newton which is moving in the positive direction. So that would be plus 70, and then I have 30 newton which is moving in the negative direction of the number line, so that would be negative 30. So when they add them together, plus 70 minus 30 would result with 40 Newton as my net force. Another example, let's say I have, two forces which is acting here, 70 newtons, let's say another force which is 30 Newton, and then another force in the opposite direction to it, 40 Newton, right? Again, going with positive and negative on the number line, we have 70 Newton which is acting in the positive direction plus 30 Newton, right? And then what do we have? Negative 40 Newton. So I'm going to add these two first. So that will result with 100 Newtons minus 40 Newton, correct? Which results with 60 Newton, right? Plus 60 Newton. Remember, we're talking about force. Force is a vector, so it will always have this direction, and that's the reason I specifically wrote that plus sign. That means my net force will be acting in the positive direction. So the next important topic is equilibrium, or this is also termed as mechanical equilibrium. Mechanical because we are dealing with classical mechanics part of it. That's the first initial part in physics. Okay, so let's take an example. We already looked at one, but let's say you have an object, right, which experiences multiple force. Let's say I have 10 Newton, right, which is acting in the positive direction, and another 10 Newton which is acting in the opposite direction to my first initial force. Okay, so there are two forces which are equal in magnitude but are acting in opposite direction. So let's add them together, or in other words, let's find the net force, right? So that's what we're going to find out. So net force in this case would be, I have 10 Newton minus 10 Newton results with 0 Newton. 0 Newton. Okay, now the force is 0. External force is 0. By Newton's first law, an object stays at rest or an object moves at a constant speed, right? Unless and until an external force acts on it. Okay. When my net force is 0, that means object should be at rest, correct? So object is at rest, or object should be moving with uniform speed or constant speed. So for an object to be at equilibrium, the net force or combination of all the forces should be 0. In other words, object can be at rest, so that's my first factor, or object can be moving with uniform speed. Okay, so equilibrium of moving object, or in other words, moving object can also be in equilibrium. So how is that possible? Equilibrium state, when we talk about that, what is it? It's of no change, state of no change, correct? So when an object is moving with, let's say, constant speed, constant, what does this mean? No change. It's perfectly possible for a moving object to go into equilibrium. So there are two equilibrium states that we talk about. One is static equilibrium. The other one is dynamic equilibrium. So what does static mean? Static means when an object is at rest. So when an object is at rest, it achieves static equilibrium state. When an object is moving, right, but with uniform or constant speed, that's when it achieves dynamic equilibrium. So there are two types of equilibrium. Moving object can also achieve equilibrium perfectly fine. So that's it for today, and I'll see you guys in my next lecture, linear motion, and bye-bye.